Welcome to the DIY Honda Garage channel. This troubleshooting guide provides a systematic approach to diagnosing and resolving the DTC P0172, which indicates that the fuel system is running too rich in the Honda Accord models from 2012 to 2017. A rich fuel mixture means there is too much fuel and not enough air in the combustion chamber, which can cause poor fuel economy, rough idling, and increased emissions. The guide emphasizes the importance of recording freeze-frame data and snapshots before testing to preserve diagnostic information. It also advises not to clear the DTC or reset the PCM prematurely, as doing so can erase valuable data. The procedure steps guide the technician through verifying symptoms, checking sensor signals, inspecting fuel pressure, and verifying component health to locate the root cause of the rich mixture. The ultimate goal is to identify whether the problem stems from sensors, fuel delivery, or other mechanical issues to ensure accurate repairs and vehicle performance restoration. If all previous checks are normal, but the fuel mixture remains rich, the oxygen sensor or AF sensor may be faulty. The AF sensor detects the ratio of air to fuel in the exhaust gases and provides feedback to the PCM for accurate fuel control. Replacing the sensor with a known good unit ensures the sensor's reliability, especially if it appears damaged or contaminated. After replacement, the PCM is reset using the HDS, and the idle learn procedure is performed to recalibrate the system. The vehicle is then operated under similar conditions to see if the rich condition persists. If the AF/FB readings return to normal, the sensor was causing incorrect fuel mixture signals. If not, further diagnostics are necessary. The final step involves resetting the PCM, which clears any stored DTCs and prepares the system for relearning. This is followed by executing the idle learn procedure, which allows the PCM to recalibrate fuel trims for optimal operation. After completing these steps, the vehicle should be driven under the same conditions when the low AF/FB was observed. Monitoring the fuel trim parameters during actual driving gives confirmation that the issue has been resolved. When the AF/FB stays above the 0.79 threshold and the fuel trims stabilize, the repair process is considered successful. This step ensures that all previous repairs and component replacements have restored proper fuel mixture control. Preventive maintenance plays a critical role in avoiding future issues related to rich fuel conditions. Regular inspection of the fuel system components, including the fuel tank, pumps, and filters, helps ensure proper fuel delivery. Using high-quality fuel minimizes the risk of contamination or deposits that can affect sensor readings and fuel mixture. Maintaining sensors by cleaning or replacing as necessary prevents erroneous signals that might lead to rich or lean conditions. It is also important to keep air intake systems, MAF sensors, and oxygen sensors in good condition through periodic checks. Adhering to these maintenance practices promotes reliable engine performance and longevity, reducing the need for extensive repairs and diagnostics in the future. In summary, diagnosing P0172 requires a methodical approach starting with verifying symptoms and examining sensor signals. Essential checks include fuel pressure on both sides, sensor readings, fuel quality, and mechanical conditions like oil and injectors. Understanding the roles of components like the MAF sensor, oxygen sensors, and fuel injectors helps pinpoint the root cause. When repairs are completed, proper system resets and learn procedures confirm stability. Routine maintenance and using quality parts and fuel contribute significantly to preventing recurrence. Always document your findings and validate repairs with real-world testing to ensure the vehicle returns to optimal operation, providing reliable and efficient performance for the owner. The first step involves starting the engine and allowing it to idle without any load, ensuring the automatic transmission is in park or neutral, or the manual transmission is in neutral. Using the Honda Diagnostic System, HDS, you observe the short-term fuel trim, designated as AFFB, which indicates how the PCM is adjusting fuel delivery. If the AFFB value is less than 0.79, it confirms the fuel mixture appears too rich at idle, consistent with the DTC P0172. This initial verification helps determine whether the system is functioning abnormally at idle, which is critical since many fuel-related issues manifest under idle conditions. Recording this data provides a baseline for comparison during further troubleshooting. If the value is within normal range, further steps are required to pinpoint the issue. Next, the technician examines the onboard snapshot data captured during previous operation. This data includes engine speed, vehicle speed, relative throttle position sensor, and accelerator pedal sensor readings at the time when AFFB was at its lowest point. Reviewing these parameters helps identify whether abnormal sensor signals coincide with the observed rich fuel condition. Subsequently, the vehicle should be driven based on the recorded snapshot conditions to observe if the low AFFB persists under similar circumstances. The driver's input and ambient conditions are important for reproducing the issue consistently. If the AFFB remains below 0.79 during this test, it confirms a persistent rich mixture, directing the diagnosis towards specific sensors or fuel delivery components. Ensuring proper fuel pressure on the low pressure side, typically measured at the fuel tank or fuel pump, is crucial. The acceptable pressure range is between 390 and 440 kilopascals, equivalent to 4.0 to 4.5 kilograms force per square centimeter, or 57 to 64 pounds per square inch. Using the HDS or a dedicated pressure gauge, the technician measures the fuel pressure, while the engine idle codes indicate a rich fuel mixture. If the pressure falls outside this range, it suggests a problem with the fuel pump, fuel filter, or fuel tank unit, necessitating replacement. Correct fuel pressure is vital because inadequate pressure can lead to improper fuel atomization and mixture. If the pressure is within specifications, further testing of high-pressure systems is recommended. This step involves verifying the high-pressure fuel system, which supplies fuel to the fuel injectors. The engine should be turned off and then restarted, and DTCs cleared to ensure accurate diagnostic data. Afterward, the engine is idled at approximately 3,000 RPM, while the radiator fan cycles on, simulating conditions under which the rich mixture may be problematic. Using the HDS, the technician performs a diesel injection fuel pressure test, and the system must indicate normal pressure. If the pressure is not within specifications, the troubleshooting process directs to specific DTCs related to fuel rail pressure sensors, P0087 or P0088. Correct high-pressure fuel delivery is essential for proper engine operation, and any abnormalities here can cause the fuel mixture to run too rich. If the high and low fuel pressures are adequate, the next step examines whether contaminated or poor quality fuel is the cause of the rich mixture. Refueling with certified, good quality fuel helps eliminate contaminated fuel as a variable. Removing and draining the fuel tank unit, then refilling with fresh fuel, ensures consistent fuel quality. After refilling, the vehicle is restarted and tested under the same conditions where the AFFB reading was low. If the AFFB remains below 0.79, the fuel itself is unlikely to be at fault. This step helps rule out fuel contamination or issues related to recent refueling, such as using low-quality or contaminated fuel, which may cause erratic fuel trims. The mass airflow sensor, or MAF sensor, measures the amount of air entering the engine, which directly influences the fuel mixture calculation by the PCM. At this point, the engine should be idling steadily, and the engine coolant temperature sensor, ECT, must be above 158 degrees Fahrenheit, indicating the engine has reached proper operating temperature. With the engine at 2,500 RPM, the technician reviews MAF readings. Acceptable values are between 6.5 and 9.1 grams per second for automatic transmissions, and 5.5 to 7.7 grams per second for manual transmissions. If the MAF reading is outside these ranges, it suggests the sensor is faulty or damaged, possibly caused by a cracked intake or incorrect installation. Replacing the MAF sensor or inspecting for intake leaks is the recommended correction. This step assesses possible influence of engine oil on fuel trim readings. With the engine idling, the PCV, positive crankcase ventilation vacuum hose, is gently pinched to observe the engine's response. The AFFB, or short-term fuel trim, is monitored. A value less than 0.79 indicates normal conditions. If the fuel trim exceeds this threshold, it could be caused by contaminated oil, which may introduce unmetered air or affect sensor readings, or by other engine faults. A contaminated oil leads to poor engine combustion and abnormal sensor signals, which could mimic a rich condition. The correction involves replacing the engine oil and filter and investigating potential sources of oil contamination or engine mechanical issues. When fuel trims remain abnormal, despite normal pressures and fuel quality, suspect faulty fuel injectors. Turning off the engine, the technician replaces the injectors with known good units, ensuring the spray pattern and flow rate are correct and that they are properly installed. After replacement, the engine is restarted and driven under similar conditions where the AFFB was below 0.79 previously. If the fuel trim values remain low after swapping injectors, the issue likely does not originate here. Otherwise, if the trims normalize, then defective injectors were causing excess fuel flow, and replacement resolves the problem. Proper injector operation is essential to maintain the correct air-fuel mixture. Please like and subscribe to the channel. See you next time.